demand curve illustrates the relationship between the quantity of a good demanded and some aspect of the economic circumstances that individuals face. Those economic circumstances include income, the price of the good that we're interested in, and the prices of other goods. We've therefore come up with three different types of demand curves: income demand curves, which are also called angle curves, own price demand curves, which we often just refer to as demand curves, and cross price demand curves. Each of these is derived from the demand function, where a demand function tells us how much a consumer will consume of a particular good as a function of the consumer's economic circumstances. In other words, as a function of the consumer's income, the price of the good we're interested in, as well as the prices of the other goods. Deriving a demand curve from this demand function simply involves holding all but one of the economic variables fixed. So if, for instance, we want to derive the income demand function, we hold all prices fixed and therefore create a function that's a function of simply one variable, income. We furthermore have to invert it in order to actually create a demand curve, because demand curves are usually drawn with the economic variable on the vertical axis and the quantity consumed on the horizontal axis. In this graph here, we'll show income demand curves for Cobb-Douglas tastes, where the good x1 has an exponent of 0.75 and the good x2 has an exponent of 0.25. In equation 9.4 of the text, we derive the demand functions for Cobb-Douglas tastes. The function for good 1 is simply x1 is equal to alpha times I divided by p1, where alpha is the exponent on the x1 good in the utility function. In our case, that exponent is 0.75. If we want to draw an income demand curve, we then have to hold price fixed. So suppose that we fix p1 at 1. The demand function then becomes x1 equal to 0.75 times I, where I is income. Since we put income on the vertical axis of our income demand curves, we now need to invert, that is to solve for I. In other words, we'll get I is equal to 1 divided by 0.75 times x1. 1 divided by 0.75 is equal to 4/3, and so the curve that we get is a curve that begins at the origin and has a slope of 4/3, indicating how, as income increases and the price of good 1 stays at 1, our consumption of x1 changes. In panel B, we do the same for x2. The Cobb-Douglas demand function for x2 in equation 9.4 of the text is x2 is equal to 1 minus alpha times I divided by p2, where 1 minus alpha in our case is equal to 0.25, the exponent on the x2 good in the utility function. If we assume that p2 is equal to 1, and thus the price of good 2 is also equal to 1, then this function becomes x2 equal to 0.25 times I. If we then want to graph the income demand curve, we need to solve for I in order to invert the function. Thus we get I is equal to 1 divided by 0.25 times x2. 1 divided by 0.25 is equal to 4, and thus gives us the slope of the income demand curve when we fix p2 equal to 1. Now, since we're holding the prices fixed when we graph the income demand curves, changing the prices will also change the income demand curves. For instance, if we change the price of good 1 to 1/2, we get a new magenta income demand curve that has a shallower slope. The same happens if we change the price of good 2 to 1/2. Another way to see this is to solve first for the inverse income demand functions, which is done in equation 9.8 of the text. Here, for good 1, we have I1 equal to P1 times X1 divided by alpha. Alpha in our case is 0.75. 1 divided by alpha is 4/3. If we set P1 equal to 1/2, then this function becomes I1 is equal to 4/3 times 1/2 times x1. 4/3 times 1/2 is equal to 2/3, and so we get a slope of 2/3 when we assume that the price of good 1 is equal to 1/2. We can do the same thing in panel B by looking at the second inverse income demand function in equation 9.8 of the text. That function is I2 equal to P2 times x2 divided by 1 minus alpha. 1 minus alpha in our case is 0.25, the weight on the x2 good in the utility function. 1 divided by 0.25 is 4. If we set P2 equal to 1/2, we therefore get a function I2 is equal to 4 times 1/2 times x2. 4 times 1/2 is equal to 2, and we therefore get a slope of 2 when we set the price of good 2 equal to 1/2. And if we further lowered the prices of the two goods, we'd get a further rotation of the income demand curves, which we could calculate in exactly the same way as we did in the previous panels. Notice that Cobb-Douglas demand functions are unique in the sense that the only price that matters for the consumption of a particular good is that good's price. In other words, P2 doesn't show up in the demand function for good 1, and P1 doesn't show up in the demand function for good 2. That's unusual, and it's a special case. If we had a demand function that included other prices, we'd have to hold those fixed too, in order to derive the income demand curves for one particular good. As the price of good 1 drops, we therefore see our income demand curves moving to the right, or in our case rotating to the right. This implies that as income stays constant, if the price of good 1 falls, we'll end up consuming more of it. The same happens in panel B for income demand curves for good 2 when we drop the price of good 2. Notice that these income demand curves are straight lines. The reason for that is that Cobb-Douglas tastes are homothetic, which means that as income increases, consumption increases by the same proportion. In other words, consumption increases linearly as income increases. Unless a good is a given good, it'll always be the case that if we drop that good's price, the income demand curve for that good is going to move to the right. This is because it's only for given goods that when we hold income constant, will a consumer consume less as the price drops. Here, the consumer consumes more as the price drops when we hold income constant on the vertical axis, and therefore we have a non-given good. This is of course true for Cobb-Douglas tastes because Cobb-Douglas tastes represent goods that are normal goods.